Is it on now?
Yes.
Wonderful.
Yay.
Okay, so we start on the left side, this kite-looking thing, which is not a formula on our chart, so we look to break it into shapes we do know.
Triangle.
So we can break this into triangles. So you could break it into top and bottom. We could do left and right, or you could find 4 individual triangles. Jeremiah. I would go with top and bottom. So if I'm looking at this triangle here, I know my formula for area of a triangle is A equals what?
Half times B.
Half times the base times the height. And we keep saying base and height are related how?
Because top and bottom, they're on the same shape.
No, nothing even close to that. Base and height always make what? A right angle. Good. So we have a right angle here, so we can say our height is what? 3. And we can say the base is all of this here,
14.
which is 14, because 7 and 7 is 14. So we have 1/2 times 14 times 3. All right. So we could do 14 times 3, or we could do half of 14.
7 times 3.
So half of 14 is 7 times 3 is 20. So is that the final answer? No. So if our top is 21, is our bottom any different shaped? No. So that would also be 21, so we say what? So like everything else in the universe, the answer is 42.
So what do you do with the 9?
Nothing. So, confuse you? Okay. So now the second one. Do we have a name for that shape on the right?
Parallelogram. Well, let's see,
No.
there's a rectangle.
Okay. No, there's not a name for this shape. Which means we need to break this into shapes we do know. There's a couple different ways we could do this. I'm going to do it the simplest way I can think of, which is just to make one dotted line going straight down. That'll give us one rectangle, one triangle, and one square. Okay? So let's start with the smallest piece. How about this square here? That'd be 4. 2 times 2 is? 4. Right? And let's go to the rectangle. This would not be 12 times 20.
10.
Why is it 10, Jeremiah? Because this 2 is already accounted for. So this entire length here is 12, but this purple piece is 2, which means this red piece has to be 10. So a rectangle is 20 times 10. If our formula is base times height, 20 times 10 is 200. Okay, that just leaves our triangle. So what would be this length right here?
5.
Would be 5, because if this is a rectangle, if the bottom is 10, that means the top also has to be. And for this entire length to be 15, that means this leftover part has to be 5. Okay. And then this other piece we look at, this length here is 13. This purple piece is 2. But the entire length all the way down is
20.
So we say 13 plus 2 plus what is 20? 5. So do we see how this side right here, all of this, has to match all of that, which is equal to 20. So these 3 numbers have to add up to 20. So we have a triangle. This is a right angle here. So what is our base and height?
5.
They're both 5. Do we care about this long side here? No. Oops. Half base times height. So base is 5, height is 5. We want half of that. So 5 times 5 is, and then half of 25 is
16 and a half. No?
is what? 12.5. At some point you should learn how to divide odd numbers by 2. It's usually not that bad. If you take 1 away from it, so what's 1 less than 25? 24. Half of 24 is, but since it's odd, we know it's got to be 12.5. Anytime you divide an odd number by 2, the decimal is always 0.5. Okay, so what's our final answer? We have to add it. So we add the area of the triangle. What do we add that to? To the area of the square and also the area of the rectangle. So we say 200 plus 12.5 plus 4.
212. No, it is 216.
I know that. So that just give us an answer of 216.5. Okay, so problems like this, you need to know how to find area of a regular shape, which looking at your quizzes, some of you didn't really know how to do. You also had to know how to create those shapes, which, again, some of you seem to struggle with. There's different ways you could have done this. Whoops. I thought the regular one was just part of it. So let's try to erase the stuff in the middle here. We also could have split this up. We could have made a trapezoid up top, found the area of that. And then we also could have made a rectangle like that, and then a long, skinny rectangle. That also would have given you the right answer. Okay? Any questions on area? Yes?
Is it true that the area of a trapezoid is the same equation as an area of a parallelogram, such as a square or rectangle?
You could find the area of a square or parallelogram using the formula for area of a trapezoid. Yes? So you're done. All right, for today, we're going to go back, talk a little bit about dilations. So you should be on the side of this paper that says reteaching.
4.5?
Yes. Okay, number 1. The very first thing you have to do on this left side, right here, you're going to plot these 4 points. So do that now. Just plot A, B, C, and D on the left side. Yes, and then connect them. Alright, so we should have our points negative 1, 1. So there's A, positive 1, 1, 0, negative 1, and negative 1, negative 1. Which makes what kind of shape? That's definitely not a square. It is a trapezoid. We know it's trapezoid because it's got exactly one pair of parallel sides. Alright, then it says we want to increase that by a scale factor of 2. So we did this a little bit before with leaves, right? And we said all we did is we took these points and we multiplied x and y by 2. So what's negative 1 times 2?
Negative 3. No, it's not. Negative 2.
Is negative 2, thank you. Positive 1 times positive 2 is positive 2. Alright, so b prime, 1 times 1 is, or 1 times 2, good job. 1 times 2, again, good job. Alright, c prime,
0.
0 times 2,
0.
very challenging, 0. Negative 1 times 2, negative 2, we're all so smart. And then d prime, negative 1 times 2,
Negative 1. Negative 2. Negative 2.
negative 2, negative 2. Okay, great. Alright. So what we're going to do with these new points is you're going to take those points and you're going to put them into the right side grid. Do that now. Then you're ahead of the game.
Just make it a little bigger.
And what do these little apostrophe looking things mean again? So prime, what does prime mean? Well, it's not the original, it's where it's been transformed to. Anytime we have to move a point for any reason, it's still the same point, just in a different spot, so that's why we call it that number prime. And then negative 2, negative 2. Oh, my bad. Was testing you. You passed. So we connect those. What should we end up with? We should get the exact same shape, only a bigger size. Okay? If we look at this relationship, let's look at the perimeter. How would the perimeter change here?
Let's just get a little larger.
How much larger?
2 times.
So the perimeter would get perimeter would be 2 times the size. Okay, because all of our side lengths are being doubled. Okay, how about our area though?
Area would be No, it'll stay the same.
I don't know.
Well, think about that. We'll come back to it. All right, try number 2. Yes. So what's going to go on the left side?
The original.
So you're going to put the original points on the left. If it says a scale factor of 1/2, what does that mean you're going to do with all of our...
Divided by 1, 2.
That means you're going to take all the original points, you're going to divide them by 2, or multiply by 1/2. So -2 divided by 2 would be
2.5. I mean,
-1. 2 divided by 2 is 1, and a negative divided by a positive is negative. So I'll give you a chance to redeem yourself. -2 divided by 2. 1. I'll give you another chance to redeem yourself. For B, -2 divided by 2. -1. And then 2 divided by 2. 1. Now we're cooking. All right. So finish that up. Plot both your shapes out. This shouldn't be too hard since none of the numbers are greater than 2.
It's just 0.
What's anything, or what's 0 divided by anything? 0. And again, what should our two shapes, what should they look like? But how should they should be the exact same, what? Shape, but different size. So is he correct? What's the problem?
He did 0 to not 2 2.
Oh, yeah. No.
He's messed up. Oh, he got 0.
D is a little messed up. So let's see.
Oh, his line is straight.
So what happened here? So is A correct?
Yes.
Is B correct?
Yes.
C correct?
Yes.
But where's D supposed to be?
On the 2.
It's supposed to be at 2, 0. So it should get a shape that looks kind of like that. Okay.
Why didn't you get that?
All right, and then our dilation in red, preferably. So we're pointing at -1, -1. I have a point at -1, +1. At +1, +1, and our last one at 1, 0. Okay, we agree? A little small. The only thing we're really missing, and I'm going to assume it's there, we just can't see it, is we should put the little prime symbols. Because if we put A, how would you be able to tell the difference between this and this? But still, you'd be saying, if this is point A, and this is point A, they'd be the exact same thing, and that'd be confusing. So that's why we put the little symbols on them. That's why we put the symbols on. And I guess I could remember to do that too. Okay? So what would happen to our perimeter here?
It got smaller.
By how much? So our perimeter would be times 1/2. How about our area?
Got smaller.
Got smaller by how much?
Half.
You sure?
No, it got smaller by one. Yeah. By one.
We're not sure, so we'll come back to it.
Are we gonna do that on everyone?
How about number 3? Actually, we're going to stop here because we can find the area of this one pretty easily. So again, just like before, put the original points on the left. Find the scale factor. If scale factor is 1/2, that means what are we going to do with all of our sides?
Wait, why is it the same? Yeah, it's the same. No,
Different numbers, though.
No. Just the last one's different.
Okay, well then this should be very easy.
Yeah.
So A prime would be what, Lamar?
Oh, 1. -1.
-1 what? -1. Okay?
1, 1.
So plot the originals on the left, new points on the right. You should get two shapes that look very similar. Almost too similar. So our original shape is indeed a square. What are our new points going to be? B prime would be what? -1, 1. C prime? 1, 1. Okay, so it'd be the same thing, only all right, so we're going to again look at perimeter and area. So this one is pretty easy because it's a square. We can actually work this out. What is the side length? How far is it from B to C? 4. How far is it from A to B? 4. Okay, yeah, it's a square. What's the perimeter of that?
16.
So the perimeter of this is 16. How about on our smaller shape?
8. 4. 2.
What is the length of each side?
2.
2. Which means that's a perimeter of
8.
8.
I know what it said first, and you're like,
I know, but some people are saying 4, and that scares me. 4K. Why? No. Okay, so how are the perimeter of the two shapes related? Whoops. How do you get from 16 to 8?
divided by 2.
Divided by 2, which is the same as multiplying by 1/2. Which is multiplying it by the what? The scale factor. Which is what we said here, which is what we said here, right? Okay. How about the area? What is the area of our blue square?
16.
Is also 16. Just so happens to be 4 times 4 is 16. How about the area of our red shape? It's not 8. 2 times 2 is? So what did we do there? Well, how are they related? Say it louder. We divided it by 4, which is the same as multiplying it by 1/4. Okay, so how does that happen? Why is that not the same as perimeter?
Because area is the whole thing and perimeter is just the outside.
That is true, but what does that have to do with the scale factor? Settle down, Rain.
What I said.
What you said? Well, let's look at it. How did we get the area of the blue shape?
We multiply 4 times 4.
We said 4 times 4. So 4 times 4, that's how we got the area. Okay? Over here, where did 2 come from? How did we get 2? Because we took half of 4. So in reality, we're saying to find the area of this, that 2 came from 4 times 1/2, correct? Yeah. Times this other side, which is also 4 times 1/2. Okay? So then we still have this 4 times 4. And what's 4 times 4? 16 times 1/2 times 1/2. And what is 1/2? What was that? But no, what is that? Where did 1/2 come from? That's the scale factor. So when we do area, because it's in 2 dimensions, we're taking that scale factor and multiplying it by itself. So what's 1/2 times 1/2?
1/2. 2 4.
Okay, what's 1 times 1? 1. Good. What's 2 times 2?
I said that.
I know some people did, but then a lot of other people are like 1, 1/2. Somehow magically 1/2 times 1/2 still equals 1/2. No, it's 1/4. Which is what we said was the relationship for the area. So an easy way of saying this is we take, it's always going to be times the scale factor, what? Times itself, or scale factor squared.
So how does the 2/2 get smaller to a 4?
Because anytime you multiply fractions, the numbers get smaller. Because you're saying you want half a group of 1/2. Yes.
But how is that one work? Is it
What's half of a half? Like if you have a pizza and you only have half a pizza, right? You only have, this half's gone. And then you want to give your buddy half of that. How much did they get? They got a quarter. Okay, half of a half.
What's half the quarter?
Half of a quarter
A penny.
is one what? Eighth.
And then what about that? What is 16? What about that?
Yeah, yeah.
1/22.
1/24?
All right.
It'd be 1/30.
Guys,
So-
just stop talking.
So how about this one here? We said the perimeter was 2 times because the scale factor is 2. But here it would be times the scale factor what?
So,
What do we say?
itself.
Times itself. So it'd be times,
2.
so 2 squared is?
4.
So how is the area of this related to the area of that?
It's times
This would be times
4.
4. Okay? And that saves you a lot of trouble of having to find the area of one trapezoid, finding the area of the second trapezoid, and then considering how big they are compared to each other. If you can remember, the difference in area is always the original area times the scale factor squared. The perimeter is just the original times the scale factor not squared. What? Okay, cool story. All right, so number 4. We can knock that one out real quick, yes?